In this video, I'm going to show you how to create magic squares of various dimensions. So here is the 3 by 3 magic square, and just one observation is that if I'm going to use the numbers 1 through 9, and I want to know what the sum should be, because in a magic square, the sum of every row, column, and diagonal should be the same number. So we might wonder, well, what is that number supposed to be? That could be useful. What is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 divided by 3? A trick for adding consecutive integers is to add the first and last, which is 10, then the second and the second to last, which is also 10, and the third and third to last, which is 10, and 10. So we have 10, 20, 30, 40, or 45 over 3 equals 15. In general, 1 plus 2 up to n is n plus 1. And how many pairs are there? Well, there's n over 2 pairs. Now, let's apply this to, okay, so the magic number is 15. So how do we get 15? Well, through some kind of trial and error process, you'd probably come up with the answer. There's various ways to write it. Here's one of them. Now the 5 has to be in the middle because it's part of 4 different sums, but the 8, for instance, can't be in the middle because 8 plus 7 is 15, and 7 can be written as 6 plus 1, or 5 plus 2, or 4 plus 3. So there are not 4 ways to write 15 as a sum, which use the number 8 in them. Now the number 9 needs to go, so there's the center square, there's the 4 corners, and then there's the edges. The number 9 plus 6 is 15, but 6 can only be written as the sum of 5 plus 1 and 4 plus 2. We can't use 3 plus 3 because there's only 1 3 allowed. And that's why the numbers 9 and 1, well, that's why 9 has to be on the edge, but we could say the same thing for 1. Anyway, with some messing around, you'd probably come up with this. But when you move to a larger square, like 4 by 4, it's pretty hard to get the numbers 1 through 16. We could figure out what the magic sum is by saying what is 1 plus 2 plus all the way up to 16, and it's going to be 17 times 16 over 2, which is 17 times 8. Sorry, divide that by 4, because if we kind of look at the 4 different rows only, divided by 4, so now I can cancel that and get 34 as the magic number. But actually finding it is gets pretty hard, it seems. So I'm going to show you 3 algorithms for creating magic squares. One for odd numbers, and 2 different ones for even numbers. I'm going to start with the odd numbers since we have the 3 by 3 one. Here's the algorithm for magic squares of what's called an odd order. You put the 1 in the center of the top row, and since it's an odd number of dimensions, since it's a 3 by 3 in this case, there will be a center. And then, the place you put the 2 is you always follow the same pattern. You go up and to the right. Now when you go up, kind of like an old-fashioned video game like Pac-Man, when you go up, you reappear over here. You go up, you reappear over there. Then you go to the right, and you put the 2 there. Then to get the 3, you go up from where you were at the 2, and you go to the right, but you loop around like you do in like Pac-Man or Asteroids to there. Now when you try to go to the 4, you go up and to the right, but there's 1 there. So what we do instead is we put the 4, if there's already a number in the up and to the right spot, we instead go back to our number 3 and instead go under it. Now you might say, what if there's something under it? Well, there won't be. So now I go up and to the right from the 4, up and to the right from the 5, up, I end up at this 2, to the right, can't put the 7 where the 4 is, so I put the 7 underneath the 6, up, and to the right, get the 8, up, get here, and to the right, 9. Okay, you can mess around with that, and amazingly, you'll see go up and to the right, so 16. And believe it or not, that is the magic square. If you don't believe it, that the sums are right, the sum should be 1, 2, up to 25 over 5, which is 25 times 26 over 2 over 5. Cancel those out. Cancel those out. Get 65. And you could check that the 12 different sums, the 5 rows, the 5 columns, and the 2 diagonals all add up to 65. Now there are, I should mention, more than one way to make a magic square. With a 3 by 3, any way that you make is going to be like some kind of rotation or reflection, and it doesn't really, you might think if it does that count as a new one? And I would say no, there's really only one way to do the 3 by 3 magic square if you count a rotation of it to be the same thing. But if you do the 5 by 5, there's many different ways to do it. This is just one of them. So that takes care of the odd cases. But what about the even numbers? Well, for even numbers, I think I'm going to start with there's 2 types of even numbers. There's even numbers that are divisible by 4, like 4, 8, 12. And there's even numbers that are not divisible by 4, like 6 and 10. So this one is not divisible by 4. That's actually the easier kind. So a 6 by 6 or a 10 by 10. The way we do one that's not divisible by 4 is we split it up into 4 equal pieces. And each of these pieces is going to have an odd dimension because this thing was not divisible by 4. So if you divide something, if something is divisible by 4 and you divide it by 2, the answer will also be divisible by 2, so it will be even. Half of a number divisible by 4 is even, but half of a number that's not divisible by 4 will be odd. Now the order, I'm going to go like this, A, B, C, D. So the 4 pieces I'm labeling, A is the top left, B is the bottom right, C is the top right, D is the bottom left. And now what you do is you actually do the odd, the thing I just showed you, to make a magic square in the top left. Now we move over to B and put the 10 in the top and do the exact same process. 10, 11, 12, 13, 14, 15, 16, 17, 18. Move over to B, 19, 20, 21, 22, 23, 24, 25, 26, 27. Might as well finish it. I've come this far. 28, 29, 30, 31, 32, 33, 34, 35, 36. And you could check that the 12, 6 going this way, 6, 12, 14 different answers are going to add up to over 6 plus 36. That's 37 times 36 over 2 over 6. 36 over 2 is 18. 18 over 6 is 3. 3 times 37 is 90 plus 21. Which is 111. By the way, I just remembered that we really didn't go over why this method works. I'll leave that for you to think about. I don't have a great answer for that. It's cool the way it does work, and you might notice after you get an answer like this that there's a pattern to the way the numbers sort of progress. But why this works, I'm not really 100% sure. I have to really mess around with why this method works. Okay, so we've seen the odd case and the odd times 2 case. That's even. But what about multiples of 4? Well, the way you do multiples of 4 is we cut it up into 16 equal pieces, which in this case it already is 16 equal pieces, and 4 of those equal pieces are going to be the 4 corners, so I'm going to make those red, and 4 others are kind of like in the middle. They're not attached to the edge at all. So I have the reds and I have the blues. So I split it up, and I can do this with an 8x8 also. I'll show you that after. And the way this works is, we put a 1 in the top left corner, and we count through the numbers, but I only fill in the ones that are red. So I go 1, don't put 2, don't put 3, 4 goes in there because it's in a red box. 5, don't put 5 because it's in a blue. But 6 and 7 are okay. 8, 9, 10, 11, 12, 13, 14, 15, 16. So I put in all the numbers that are in red boxes. And now for the blue ones, I start from the bottom right corner, and I count to 1 to 16 backwards, only writing numbers into the blue. So 1, don't write it, it's already a number there, but 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that is actually a magic square of order 4. It's one of them. When I throw in an 8x8, to split that into 16 pieces, 4 of the pieces are going to be 2x2s, and the other 4 pieces are going to be like this. So there's 64 numbers here, and they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. And then going backwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 57, 58, 59, 60, 61, 62. Well, you could check for yourself that that works, but magic squares have been around for a long time, and they originated in China, and different mathematicians have messed around with them. Even Benjamin Franklin really liked doing magic squares. There are many algorithms that you can look up, but I just wanted to show you, at least you have a way to do any odd number, any even number that is a multiple of 4, and any even number that's not a multiple of 4.